this is my paper about hybrid cosine-Jaccard measure for Neutrosophic set. The content of today will be introduction to similarity measures and Neutrosophic sets, similarity measures in Neutrosophic sets, and we are going to propose hybrid cosine-Jaccard similarity measure, and we are going to introduce the key properties of the hybrid measure, and we also demonstrate some numerical examples according to the properties. Lastly, we are going to compare the existing similarity measures, and we are going to have some conclusion and future research direction. Here is our introduction to similarity measure and Neutrosophic sets. In Neutrosophic sets, So the importance of similarity measures to quantifying the relationship between data points, especially in handling uncertainty and inconsistent in domains like medical risk assessment and decision making. And we have limitation on classical approaches. So we have cosine similarity measure and Jaccard similarity measure, which cannot be interpret the complexity of the data, and we also cannot handle the indeterminacy of the data set. So the introduction of Neutrosophic set by Professor Florentine is a standard fuzzy set. By considering the truth, indeterminacy, and falsity, providing a better representation for uncertainty in a data set. So here is some similarity measure that we have in classical. So cosine similarity, we are going to have all the T, R, and F, all right, through interdependency and falsity. So we are going to have also the Jaccard similarity coming from the original Jaccard formula, where we also consider the T, I, and F in Neutrosophic set. So these two classical similarity cosine, we are going to have all the measures directions not regarding the magnitude, but we also try to normalize the output where we have -1 to 1. So the classical Jaccard, we are going to have a ratio of intersection to unions. So we are going to address in Neutrosophic sets, we improvise and emphasize the interdependency so that we can handle more complexity of the data. So now we are going to define the hybrid cosine-Jaccard similarity measure.
Sorry, Dr. Lim Sai, are you using two devices at the same time?
No.
Because there is an echo here.
Yes.
Okay, thank you.
All right. Okay. Sorry. So we are going to define the hybrid cosine-Jaccard similarity measure by having the two Neutrosophic A and B, and we are going to have the cosine and the Jaccard. We have the summation of it, and we are going to have the alpha, beta as our weight. So we assume the alpha, beta are equals in weight, all right? So we are going to have the alpha, beta where the alpha, we are going to go for 0.5 and beta 0.5. So in this alpha, beta is the elements of 0 to 1. So the weight is relative important for cosine and Jaccard components. So in other words, we also consider the integrating the weight sum of cosine similarity for each Neutrosophic component, where we are going to have the weight of truth, the weight of indeterminacy. We are going to assign the falsity. So there's a typo here. So the weight of each component, we are going to have the elements, all right, in within 0 to 1. So in other words, the weights are equal. We can simplify the equation as follows. So here, after defining the hybrid Cosine-Jaccard similarity measure, we are going to have the key properties. The key properties are symmetry, boundedness, reflexivity. So in symmetry, we have in any Neutrosophic set A and set B, the hybrid Cosine-Jaccard similarity measure is symmetric, where we can written as the hybrid of A and B is equals to the hybrid of B and A. Next, we have the boundedness. In any Neutrosophic set A and set B, the hybrid cosine similarity measure is bounded by 0 and 1. So the last properties we are discussing, if the Neutrosophic set A and set B is equal, so all the components for the T, I, and F are equal for set A and set B. So these are my numerical examples to show the symmetric and boundedness properties, where I have the calculation for the classical cosine similarity first, all right? And then we have the classical Jaccard similarity. Then we are going to have the hybrid cosine Jaccard similarity measures. So we perform the alpha and beta, where we assume is equal weight. So we are going to have 0.5 for each weight. So in this, we can show I'm going to have the similarity measure as 0.84504. So the next example, we show that the reflexivity properties, where I can calculate the cosine and the Jaccard classical first, and then I combine all the cosine and Jaccard similarity using the proposed formula 0.5
Sorry, ma'am.
the Jaccard and 0.5 times the cosine. So I'm going to have 1. So this fulfills the numerical example for reflexivity. Next, we have comparison with existing similarity measure. We have cosine, Jaccard, and Hostov, and we are going to have the comparison for all the results. And we have highlighted that hybrid cosine Jaccard has balanced out all the results. It gives us a balanced result. So in other words, we have more uniforms of similarity outcomes. We also have data sets exhibit both close and divergent to Neutrosophic memberships and less sensitive to extreme values. So this is my conclusion and the future works. All right. This is my presentation. Thank you.
Thanks, Dr. Madeleine, on your presentation. Some problem for echo. There is some problem. Now we move to some remarks on your presentation. I have seen your paper. The work is good to introduce a new a new similarity index which combine cosine and Jaccard. Now I have just one remark. In your contribution, you don't have apply in a real example like decision making. Do you plan to do it in the future?
We are working on the real life application, but today's program we are going to work more onto the properties so that we can check whether it is whether it is balanced out the outputs. So the future works is considering all the application. So all the applications such as e-commerce analysis. So we are not going into this work for this paper, but we are going to we are going to work it in clearly. But today's paper is more towards properties for the hybrid cosine and Jaccard similarity.
Okay. So if there is some question from the other participants, we can contribute to improve this quality of this paper. Dr. Shanmugapriya, you are welcome with Prof. Sanders one as co-chair. So if you have some remark, you can present it.